Do you use integration services? Do you use SQL on Linux? Let's see what it takes to use SQL Server Integration Services on Linux and what you have to give up in the process. Welcome to this video on SQL Server on Linux. My name is Kevin Fiesel, and I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. The two prior videos in this series covered installation and configuration of a SQL Server 2022 instance on Ubuntu 22.04. In this video, we are going to continue the process by installing SQL Server Integration Services on a VM. Not the VM, as we'll learn along the way, but a VM nonetheless. Before I do that, however, we've got to talk about a few things. Come meet me in the classroom. The first thing I need to discuss is limitations in SQL Server Integration Services on Linux, because there are a lot of them. Let's start with some release notes. Actually, before I start with the release notes, let me drop the big one up front. There is no support for Ubuntu 22.04. You have to be running 20.04 if you want SQL Server 2022 integration services to work. This is a major letdown, so I wanted to let you down early. If that doesn't deter you, then let's go to the release notes. Right off the bat, we can see that SUSE Linux is not supported. They do support Ubuntu and RHEL, so we're okay, though it's interesting to see Steve Ballmer's favorite distribution not get any love here. After that, we have a series of things you cannot do. For me, the big one is that the Integration Services Catalog database is not available. This is one of the things that made SSIS palatable, and we get none of it. I'm already not feeling great about this endeavor. Next up, no SQL agent scheduled packages. Linux distributions do have cron jobs, which are a great scheduling system, so I'm not quite as hung up about this one, but it does make things more difficult if you're trying to lift and shift from Windows to Linux. No Windows authentication is a kick in the pants. Granted, as we'll see later in this series, setting up Windows authentication on Linux is not a trivial exercise, but this does hurt uptake. After that, no third-party components. That's my third big issue in 4 bullet points. Third-party components like Task Factory add a lot of useful functionality to SSIS and cover serious deficiencies like how bad the default logging system is. That means we've got yet another major annoyance. No change data capture is probably also a fairly big issue considering the pattern of using CDC to migrate data from an OLTP system to a warehouse. The rest of these, however, are not big on my list. SSIS scale-out was more of a science fair project than a critical component, and the rest, not worth the effort, I think. Oh, by the way, I accidentally goofed and snapped a screenshot of the SQL Server 2017 on Linux release notes for SSIS. Here, let me show you what it looks like for SQL Server 2022. Yep, that's right. Nothing has changed in 5 years. In fairness, has anything changed in 5 years on the Windows side for SSIS? Leave a comment in the notes if you know, because I don't. All right, time to stop beating up on SQL Server's redheaded stepchild. Let's go take a look at what we can do with SSIS. The first thing we're greeted with is a similar general limitations section, but we already know about these problems, so we can move on. Next up is a list of supported control flow tasks. These are some of the more useful ones: bulk insert, data flow, execute SQL, execute tsql, and the like. There are also some control flow tasks that have limited support, and we can see what the limitation is for each. I haven't used execute process before, but file system and script are typically useful ones. Now, I'm not sure here if the note for the script task is that it only supports .NET Standard or normal .NET APIs. I assume it really means .NET Standard, as there technically was never an official .NET Framework release for Linux. Prior to .NET Core and .NET Standard, we used Wine to emulate .NET Framework 4, or we used a third-party stealing of the .NET Framework, but it was all for a good cause. Mono was a great product. SSIS on Linux does support some maintenance plan tasks, but my advice regarding maintenance plans is never use them. Oh, but Kevin, you might say, isn't a maintenance plan better than not doing maintenance at all? Not really. These things are slow, indiscriminate, and make it easy to do dumb stuff like shrink databases on command. Take the time you would spend building dumb maintenance plans and implement Minionware or Ola Hallengren solutions. You'll be better off for it. As far as control flow containers go, SSIS on Linux supports all three of them, so one thumb up for that. Let's now take a moment and fill in the gaps here. We've seen what SSIS on Linux covers when it comes to the control flow, but we don't have a nice list of things they don't support. Allow me to illuminate you. Using analysis services? Not here. The analysis services execute DDL and processing tasks are a no-go. Forget about any of the Azure tasks. Blob download, blob upload, data lake analytics, data lake store file system, HD Insight create cluster, HD Insight delete cluster, Hive and Pig and SQL DW upload, flexible file, all of these tasks not supported. That's because all of this stuff is covered under the Azure feature pack for SSIS, which doesn't have Linux support. Also, there is no data mining query task support. We saw in the maintenance plan section that there's no support for executing SQL agent jobs or for the notify operator task. We lose out on the message queue task, which makes sense as that relies on MSMQ and there's no reason to even want MSMQ on Linux. There are much better queuing systems. Also, we don't get the transfer tasks. Transfer databases, transfer error messages, transfer jobs, logins, master stored procedures, SQL Server objects, and select objects to transfer. I'm not sure I ever used any of these tasks, to be honest, so I don't consider that a big loss. Finally, we will not have support for the WMI data reader or WMI event watcher tasks, as that's Windows management instrumentation, so not on Linux. So that's your hit list of what not to expect from SQL Server on Linux. For the most part, I don't think there are any big losses here when it comes to built-in components. The inability to add third-party components does hurt a lot, but I doubt the majority of SSIS users even paid enough attention to the control flow task list to even know that many of these existed. Now let's look at the data flow side of the house. If we look at the supported data flow sources, it's fairly barren. Raw files and XML. Fortunately, things aren't quite as bad as they look. We can use ADO.NET, flat files, OData, ODBC, and OLADB sources and destinations. Considering that most scenarios tend to use these data sources, it does hit a pretty fair number of use cases. In looking at the limitations, I don't think these are particularly onerous, at least not for mainstream SSIS operations. Now, one data source that we don't see in here is Excel files. That is a kick in the pants, given how common Excel files are to organizations. Yeah, there are workarounds we could talk about in converting Excel files into a supported flat file format, but if I'm already using some other tool to transform an Excel file into something SSIS can use, why not just keep using that tool and skip SSIS altogether? Looking at the list of data flow transformations, we can see that most of these are fairly supported. This is also the hit list of most common transforms, by far. There are two others that I really want to see on this list, but we'll see them both on our next image. The OLADB and script components are also important for data flow processing, and they are available, but with some limitations. OLADB only supports the SQL Server Native Client 11.0 and OLADB Provider for SQL Server, and the script component only supports .NET Standard. Again, the phrasing here is a bit weird because .NET Standard isn't .NET Framework, so I think there was something lost in translation along the way. There are a few transformations that we do not see on either list, but most of those are very uncommon. Term extraction goes with term lookup, but while we have term lookup, we don't get term extraction. The data mining query transformation helps us run data mining queries, but we already knew that functionality wasn't available to us. The DQS cleansing transformation lets us use data quality services, a feature that hasn't seen love in, 15 years? I'm not too heartbroken about any of these so far. Percentage sampling and row sampling are two additional transformations we will not get on Linux. These could be useful, but to be fair, I don't remember the last time I used either of the transformations. And now I have used the cache transformation in the past as part of tuning SSIS operations. It's a bit of a shame we don't get SSIS caching, though that was always more of an advanced use case and not something you saw many packages use. That's our set of components. Now let's get out of the classroom and into a demo and see how things work in practice. Here we are in the Ubuntu virtual machine that we used for the first pair of videos. We're going to do a couple of things here in this video. First, I'll install SQL Server Integration Services for Linux. Then, I'll show you how to deploy packages to a SQL Server on Linux instance running the SSIS service. We'll see how things go when the packages run normally and when we include inaccessible components. After that, we'll look at SSIS package management, knowing that we won't get to take advantage of the Integration Services catalog. Finally, I'll show you how to schedule SSIS jobs with Cron, as we won't get to use the SQL Server agent to run our SSIS packages. So let's get to it. To install SSIS, we would first need to get the Microsoft Public Repository GPG key and add Microsoft's SQL Server repository for Ubuntu 2204. We already did that in the SQL Server on Linux installation video, so I won't repeat that here. Instead, let's start with the command to install integration services. And it's not available for Ubuntu 2204. Listen, I'm really not trying to rag on SSIS here, but it's hard to do so when there are so many limitations and I can't even run it on the mainline version of Ubuntu. But because I didn't just want to leave you in the lurch, dear viewers, I went and built an Ubuntu 2004 LTS virtual machine and installed SQL Server on it. That way, we could still see what SSIS gives us. Don't worry, in the next video, we'll get back to Ubuntu 2204. Now that we're on this 2004 virtual machine, let's try running this command a second time and see what we get. Looks like after installation, you do need to configure SSIS. I'll use the interactive configuration tool SSIS conf. I want to use developer edition, so I'll select 2 here. I agree to the license terms, of course, so this time I'll type in the word yes instead of just a capital Y. And that does it for setup. There is one last thing the guide recommends, and that is to add SSIS to your path. I'll open up .bash rc, which controls configuration for my sessions. But first, I need to make sure I have Vim installed so that I don't have to deal with raw VI. Nobody loves raw VI, or at least I don't love it. Now, let's scroll down to the bottom of .bash rc. Down here, I can add the following line to get SSIS's bin directory added to my path. Now that I've done that, let's rerun .bash rc to grab that new path element. And if I echo the path, I can see SSIS at the front. So now we're ready to go. By the way, I've already loaded some sample data into a forensic accounting database. Let's hop over to SQL Server Management Studio and see. We can see, as I drill into this database, that there are several tables already there. It's all artificially generated data, but intended to look somewhat realistic. I've also created a couple ETL tables to demonstrate integration services functionality. These 2 tables are bus staging and line item staging. And now I'm going to switch over to Visual Studio 2022, where I've already installed the developer tools and the integration services project extension. If you don't know how to do that, check the links in the description below. They give you some instructions. I can create a new project and then create a new integration services project. Once I've gone through the template rigmarole, I now have a new package. For this package, let's keep things simple and only do what we're allowed to do. I'll drag on a data flow task and drill into it. Now I'm going to use an OLADB source and OLADB destination. So let's drag one of each on. By the way, I remember back when the SSIS team tried to get us all to move to ODBC, but you'll pry OLADB out of my cold dead hands. Once I've done this, I'll drill into the source. we need to create a new connection manager to point to our SQL Server on Linux instance. So let's select New. Then I'll create a new data connection. For my server name, I'll use the IP address of my instance. For the authentication, I need to use SQL Server Authentication, as SSIS for Linux won't support Windows authentication, even if we do get it set up correctly, which I haven't done yet. It's coming in a future video. My username is SA, and I'll pass in my password, because I haven't created an account other than SA for this server. Then, if I select the drill down, I should see the Forensic Accounting Database. This is a good indicator that my connection did succeed. Just to make sure, I'll select the button to test the connection. And it looks like everything is gonna be alright, so let's keep hitting OK until we're back in the OLADB source editor. In the table or view list, I'll select bus and then navigate to columns. I can see everything here, so we're looking good. Let's hit OK one more time. Now I need to hook up my source and my destination. Because I'm OCD this way, the vast majority of the time is going to be spent getting that arrow just right. But eventually, I will accomplish this task and then drill into the destination. I'll use the default OLADB connection manager and choose the bus staging table. There are some things we can do to optimize this SSIS package, but I only have a few rows, so I'll leave it alone. Let's next go to the Mappings tab, and we can see that everything mapped correctly, so I'll select OK. One last thing I'm going to do is right-click on the Simple SSIS project and select Properties. From there, I'll navigate into the Properties menu for the Common Properties menu and set the protection level. By default, this encrypts sensitive data with the user key, but I don't have my user key on the Linux server, so if I try to run this package, it will fail. Let's change this to encrypt sensitive with password. I'm going to use the inventive password SSIS package, and we'll need to type it in twice. Now that it's saved, we'll be able to run this on Linux. Almost. I'm also going to need to do the same for the package, so let's go back to the control flow and make sure I don't have any components selected. In the Properties window, I can scroll down to Security and check the protection level. I need to make sure that the protection level for this package is encrypt sensitive with password, and that the password is the same as for the project. If one of these differs from the other, when you try to build the project in Visual Studio, you will get an error. Now, this is a rather simplistic SSIS package, but it'll do. Now let's try to deploy the package to our SQL Server on Linux instance. If I right-click on the project name in the Solution Explorer, I can see a deploy option. I'll choose that and continue on to the next page of the wizard. My deployment target will be SSIS in SQL Server, and I'll put the IP address and credentials in that I used before. After I've filled in those details, I'm going to try connecting to it. Let's select the Connect button here and wait a few moments. So, that didn't quite work out the way we wanted. Let me select the Details link so we can see what's up. Yeah, it turns out the documentation was right. There is no SSIS DB database, so you don't get an Integration Services catalog. This means that the project style of deployment will not work. So let's hit cancel. At this point, my recommendation would be not trying to use any kind of deployment via Visual Studio for SQL Server on Linux Integration Services packages. You'll want to push them out a different way. For example, you might use SCP or Secure Copy to move files to your Linux instance. So let's do that. Here on my Ubuntu machine, I'm going to make sure I have the OpenSSH server installed. I'm also going to switch to my home directory and make a directory called SSIS. Let's quickly try to SSH into this machine. And I'm able to type in the password and get through all the necessary details to connect to the server, and okay, yes, I'm in. So we know that works, and I can exit this session by typing exit into the shell. Now let's use SCP. To do that, I will first drill into the directory hosting my SSIS packages. In here, I have a file called package.dtexec. Let's copy it from here to my test user's SSIS directory. The command to run is fairly simple, so I'll paste it in. The idea here is that we are performing a secure copy from my local machine's directory, moving package.dtexec over to the Ubuntu machine, and from there into the test user's SSIS directory. If I switch back over to Linux, and then I go to that SSIS directory, I can run ls-la and see that I do in fact have package.dtexec. So now how do we run this thing? Well, we can use the dtexec command. There's an equivalent Windows executable, and this is what SSIS is really running under the covers. The command is so much like the Windows executable that it even uses slashes for switches rather than hyphens like you would normally see in a Unix-based system. I'll need to be in the directory hosting my SSIS package, which is in the SSIS folder of my home directory. Then, we'll kick dtexec off with a /F switch saying that we want to run a single file called package.dtexec. I also need to send in a password, so I'll use the /D_E switch to decrypt using the password SSIS package. After I kick it off, we can see the results stream to the console. Now, you might be asking yourself, so where do you find the logs? Well, that's the neat part. There aren't any. We don't have the integration services catalog, so when we run things via dtexec, either you log the data yourself or it doesn't get logged anywhere else except the console window. But in Linux, logging it ourselves is pretty easy. I can use the T command to take the output from one stream and pipe it into another. Before I do this, I'll need to switch over to SQL Server Management Studio and truncate the bus staging table, as my simplistic package isn't very good. Now, back in Linux, I can hit the up arrow to recall the last statement I ran in bash, and then I'll use the pipe character to stream the output of dtexec into T. Let's add in the T command and specify that we want to write our results out to a file called package_log.txt. After I have that in place, I'll run the package again. We can see that there's no immediate impact from the T command. We still see data going out to the console output. But if I run a quick ls command in the SSIS directory, I can see package_log.txt. Let's run less and see how it turned out. There's our logged output. It's not as convenient as having the logs available to us in the Integration Services catalog, but it'll do. And now let's go back to the drawing board and mess with some invalid components. I'm going to create a new package. This one I'll rename to badpackage.dtexec. For this, I'm going to use the Windows Management Instrumentation, or WMI, interface. Let's navigate down to Other Tasks in the SSIS toolbox and select the WMI Data Reader task. I'll bring that on, but it will need a connection. To do that, I'll right-click on the connection managers and choose New Connection. From this list, I can scroll to the bottom and select WMI and then hit Add. It wants some information from me around server name and namespace. I'll leave those alone and then choose Use Windows Authentication. Let's select Test, and it works just fine because I'm on a Windows box as an administrator and I can see WMI details. Let's hit OK to finish the process. I'm also going to need a variable to store the output results. To do that, we'll need to open the Variables menu, which we can find in View, then Other Windows, and it's at the top called Variables. Inside here, I can create a new variable, and let's call it WMI output. Its data type will be object, so let me change that now. Now we can get to the WMI Data Reader task. I'll open that up and navigate to WMI Options. In the WMI connection box, I'll select my new connection. I also need a query source. Let's paste in a simple example of a query. I'll select OK after pasting it in. Now we just need a destination. I'll switch the destination type to variable. Then, if I select the ellipsis for destination, I can choose the WMI output variable. Everything looks good, so let's hit OK. It looks good in Visual Studio, so I'll save the package and try running it locally. I can do that by right-clicking on the package name and selecting Execute Package. We can see that it ran successfully, so let's stop package execution and ship it. In the Windows terminal, I'll copy bad package over. Let's hit the up arrow on the keyboard to get my prior command and switch to the name of the package that we're pushing out. Run that command and we're good to go. Back on the VM, I'll exit out of less and check my directory with ls. I can see bad package.dtexec in there, so let's give it a run. It kicks off and takes a few seconds to prepare, but pretty soon we're going to get an error. The service cannot be started. So it turns out that we were able to execute the package, but it quite reasonably fails because there is no WMI service running on Ubuntu. The last thing I want to do here is schedule some jobs. Like I mentioned before, SSIS on Linux doesn't support SQL Agent. But let's see if we can force it now that it's SQL Server 2022 and we most certainly have the SQL Agent available to us. I've got this agent installed, so let's open the SQL Server Agent node and right-click on Jobs. I'll choose New Job and give it a name like Run Package. I'm feeling pretty hopeful here. In the Steps menu, I'll select New. In here, we see some replication steps and T-SQL. There is no SSIS package option, nor is there a command line or PowerShell option to run dtexec manually. Those are things that you would see on a Windows instance, but we don't have them here, so they are not kidding about the lack of support. Fortunately, we do have one other option available to us, Cron. Cron is a scheduling service built into Linux, and it is quite powerful. In my SSIS directory, I'm going to create a new script, dailyetl.sh. I'll open it up using VI. Inside here, I'll kick off dtexec to run the package. But note that I'm going to use the full path for dtexec because I can't count on the cron service having run my bash rc script and knowing where this executable is. Now let's talk about this command that I pasted in just a little bit. We've seen the first part already, up to the double angle bracket. That double angle bracket means that we're going to write output from the standard output. In our case, normally that's a console, into a file called cron_output.txt. The bit at the end says that we're also going to write the standard error stream to this file. I'll save the script and exit VI. The next thing I want to do is ensure that this script is executable. Now I can run cron tab to get access to my cron file. I may not have run cron tab before. If not, it will create a new one and I can select my cron editor, which in my case, I'll always choose Vim. If I scroll down to the bottom of this script, I can add a new line with a lowercase o and insert my command to execute. I'm going to schedule this for 2 minutes from now, so let's enter those details. The first column is the minute of the hour, second column is the hour of the day. The next three represent day of month, month of year, and day of week, and I want it to run every day. After that, I have the command to execute, which is the daily ETL job. Then I'm going to take both of these streams and write them into the syslog, as well as using the logger command. This gets around the fact that I don't have a mail transfer agent installed on Ubuntu, and I'm also going to tag this with the phrase daily ETL so that I can find it in the system logs later on. Now, let's wait a moment or two and see if cron picks this up. Now that cron has had a chance to kick off this job, let's see what we have. If I run ls in this directory, I can see my cron output. So let's open it up with less and see what we have inside. Everything looks pretty good here, so let's check the results in SSMS. And yes, here are my 700 rows, just as I expected. So we've got that going for us at least. By the way, if there was a failure, I could learn more about it by using grep, thanks to the fact that I'm logging results to the system log. We can see that the command ran, and because there were no other lines logged, we can assume that things went pretty well. If the script were to hit a failure for whatever reason, we'd see the error message in this command. For the second straight video, we've dug in pretty deep. We looked at what SSIS has to offer on Linux and some of its limitations. We installed SSIS on a machine running SQL Server on Linux. We tried out a couple of packages and saw the fun sorts of trouble we can get into. And we looked at how to schedule SSIS package operations without the SQL Server agent. But let me be frank. I don't think SSIS on Linux is a good idea. There's too much missing, starting with the lack of an integration services catalog. The experience is clunky if you're coming over from SSIS on Windows, and it doesn't seem like it's gotten much better in the past few years. Save yourself the trouble and just deploy these packages to a SQL Server instance on Windows. We'll have links and show notes in the description below. And until we see each other in the next video, take care.